Okay, guys, problem number 10. Uh, please pay attention to this remark. I'm telling you, it's very important, okay? I know you don't take any physics at all, which is a little, uh, I wish it was different, but anyway. So, you, we may assume that you don't know any physics at all, okay? Or almost no physics. So when I leave a problem like this that involves physics concepts, or any other concepts from engineering or economics, etc., what you have to understand is that you do not need to understand in full detail all the quantities in the problem. Okay, for example, in this problem, I'm talking about capacitors. Okay, you don't know what that is. I think so. You don't really know what a battery is. I mean, you know the name of such object, but you don't really know how it works. Uh, Electrical energy, that has a precise definition, which you also don't know, presumably. Voltage source, charge, all these things. Okay, when you are faced with this sort of thing, guys, when you are given a problem about a field of knowledge which you know nothing about, you have to be flexible in the sense that if the author of the problem is more or less explaining you how how such concept or theory or whatever works in a simple enough way, you need to be able to understand. Okay, what I mean is, don't get scared, don't shy away from it, because a lot of people are going to say, no, 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 I know no physics at all, so I cannot solve this problem. How do you know? How do you know? For example, in this case, I'm explaining the basic functioning, starting from here and ending obviously right here. I'm explaining the basic functioning of what we understand by a capacitor, and I'm giving you the mathematical model of its functioning. Okay, in this case, the amount that charge that goes into the capacitor, and as a function of time, okay, starting from the moment in which you put the voltage source to the capacitor. Okay, so it behaves in this way. You may be asking, well, why does it work in this way? It just does. Okay, some people have discovered that this is the mathematical model for such device, for this, and you're just gonna use it. It's not your duty to understand the physics behind this. Just take the model and analyze it. That's the thing you can do. Okay, and I want you to have that flexibility of mind. Okay, so the first thing you're gonna do is pause this video, read the whole thing, read the whole problem, two, three, four times, as many times as necessary, in order to understand all of this basic context. It's very basic, okay? I'm oversimplifying things, and all the questions. I need you to do that first. And once you do it, let's go to, I'm just gonna give you a brief overview of what you're supposed to do in this problem. I'm just gonna help you out with this one, with question A, only with this one. You're gonna do the rest on your own. You have to do the heavy lifting, as I like to say. Okay. So I'm assuming that you already know all of this stuff. Okay. Okay. So let's go to Desmos. Okay. So as you can see, guys, the function that gives me the charge in the capacitor as a function of time looks in this way, where C1 and C2 are constants. Okay, they are just numbers like 3, 4, whatever. Okay, 1/2, 0.4, whatever. Okay, and let me plot this function on Desmos. Okay, write it down somewhere. Oops, what did I do? Okay, and let's go to Desmos. So the charge as of, well, no, f of t is gonna be equal to, I'm gonna write parentheses like this. You're gonna know in a moment why. I'm gonna write two parentheses and then 1 minus e raised to the minus t over another parenthesis. Why am I doing this, guys? Why am I leaving? I mean, you can see that Desmos is not giving me any graph because I haven't obviously stated the function correctly, right? Desmos has to have all the numbers and all the constants and all the stuff in order to plot the graph. Give me a moment. I don't know what's happening here. Oh yeah, sorry about that. Just give me a just give me a little time. Okay, there it is. Okay, so what I want you to do is this, guys. You're gonna spend some time, I don't know, some 5 or 6 minutes playing with this function. You have to play with it as if they were toys. Okay, you're gonna put some numbers in here. Okay, some constants. Make it simple. Make it integers. Let's say from one to 50, more or less. Okay, if you want to play even longer, that's good. That's good. And change them by intervals of 5. Let me give you an example. Okay, so remember, this is C1. This is my constant C1. This is my constant C2. Remember, my x-axis or my horizontal axis represents the time that the capacitor has been plugged or connected to the voltage source, the time, and this other axis represents the charge that the capacitor will acquire as a result. So let's play with these two things. Let me first keep this constant C2. I'm gonna keep it constant. Okay, I'm gonna actually keep it constant, and I'm gonna just leave it like that. I'm gonna put 10, and I'm not gonna touch it anymore. And the only one that I'm gonna change now is this one, C1. I'm gonna vary it. So first I'm gonna write 1. Let's see what happens. Okay, just get a feel. Just get a feel. Now let me go with 5, and let's see what happens. Okay. Now let me put 10, and just get a feel of how the function is behaving. The more you change these constants, you see. Look, gonna do that 5 again. 10, 15, 20, 30. Just play, just observe, just analyze the function. Oh, by the way, I should point out the following. um, Clearly this function does not have any meaning for times, on the left side of the y-axis, right? For negative times, because we don't know what that means, a negative time, right? So don't consider this part of the function. It doesn't make any sense, any physical sense. Okay, mathematically it is correct, or there is nothing wrong with it, but there is no physical interpretation for this part of the graph. So imagine that this part here doesn't exist. So as you can see, that's what you have to do. Just play with these constants, and observe and analyze and try to interpret what's happening to the charge of the capacitor with respect to time, or as a function of time, as you change these two numbers. Now let's change the other. For example, let's go back here to 10, and let's change this one. Let's see what happens. Let me put 5. Now let's go with 10. Now let's go with 20. No, 20, sorry. You see? Now 25. Now let me change this one. Let me make it a little greater. Let's write 30, and let's change this one again. 5, 10, 15, 100. Let's write 0.1. Look, look what happens when for very small, not very small values of C2. The function goes, look at the behavior. It it shoots upward like very quickly, like from 0 to this number to 30 almost instantly, and then it keeps on, like in this way. You see? So try to observe these things with care. 0 0.3, 0 0.5, 0 0.8. Look at what's happening to the graph of the function as I'm increasing this value. 1, 2, 3, 4, 5, 6. This is what you have to do, guys. Okay? Just play with this function and try to understand, try to interpret the physical meanings of this constant C1 and this constant C2. Okay? Try to give an interpretation, uh, taking into account that this, again, I repeat, this is the charge of the capacitor, and this is the time that the capacitor has been plugged to a voltage source from time 0. Okay? So struggle a little bit.